All right, let's talk about something that's, well, kind of reshaping our entire world, pretty much one data point at a time. It's called machine learning, and you might be really surprised to find out just how much it's already a part of your daily life. I mean, seriously, think about it. From your phone to your car, there's stuff happening that feels, well, it feels like magic, right? But what's really going on behind the curtain? It's not some kind of spell. It's actually a really powerful and honestly fascinating field of computer science. And the thing is, you're using it all the time, every single day. That spam filter that keeps your inbox clean, that's machine learning. The way your search engine just knows what you're looking for, yep, that too. And what about when your streaming service recommends a show that you end up loving? You guessed it. It's the smarts behind digital assistants like Siri or Alexa, and it's even the core tech in self-driving cars. So what is this invisible force? What's the technology that's powering so much of our modern world? And maybe the biggest question is, how does a computer learn to be so smart and so helpful? Well, the answer is machine learning. And here's the simplest way to think about it. It's a part of artificial intelligence, or AI. But, and this is the key part, instead of us programming a computer with a giant list of rules for every single little thing, we give it the ability to learn for itself. It learns from data, it spots patterns, and then it starts making its own predictions and decisions. So if it's learning, what's it learning from? Well, the key ingredient, the fuel for this whole engine, is data. And the amount of data we're all creating right now, it's just staggering. Just how much are we talking about? Get this. On average, about 2 megabytes of data are created for every single person on the planet. Every single second. That's an absolute flood of information. There's no way a human could ever sort through all that. So we need algorithms, right? We need something that can make sense of it all way, way faster than we can. Okay, so to make sense of all that data, we've got to give it some structure. Let's look at a really classic example here. So what you're seeing is a data set. Each row is what we call a sample. Think of it as one observation, in this case, a single flower we measured. And the columns, things like sepal length and petal length, those are called features. They're the characteristics of our sample. The whole game, the job of the algorithm, is to look at these features and learn the relationship between them so it can predict the target, which here is the flower's species. Simple as that. Okay, so we've got the data, but how do machines actually do the learning part? Well, it turns out there are basically 3 main ways they go about it, 3 different strategies, and each one is good for a different kind of problem. First up, we've got what's called supervised learning. The best way to think about this is like a student who has a teacher and an answer key. The algorithm gets trained using data that's already labeled, just like with our flowers, right? We already knew which species was which. The whole goal is for the machine to study this labeled data and learn the patterns so well that when we show it a new flower it's never seen before, it can correctly guess the species all by itself. And within this learning with an answer key method, there are really 2 main types of problems you're trying to solve. The first is called classification. This is all about answering the question, which category does this belong to? Think about sorting emails. Is it spam or not spam? That's a classification problem. The other type is called regression, and that's all about answering how much or how many. A perfect example is trying to predict what a stock price will be tomorrow. You're looking for a number, a continuous value. All right, let's switch gears to the second type, unsupervised learning. Now, for this one, imagine a detective who's just been handed a box full of random evidence. There are no suspects, no labels, no answer key at all. The algorithm's job is just to sift through all this unlabeled data and find hidden patterns or natural groups. All on its own, it's a true detective. So what can a digital detective like this actually do? Well, for one, it can do something called clustering, basically finding natural groups in the data. Think about a company looking at all its customer data. This could find groups of customers who have similar buying habits, which is gold for targeted marketing, right? Or it can do something called dimensionality reduction. That sounds complicated, but all it means is simplifying really complex data down to just its most important parts, which makes it way easier to analyze. It's all about finding that hidden structure in the chaos. Okay, on to our third and final method, reinforcement learning. This one's my favorite. Imagine you're learning to play a brand new video game, but there's no instruction manual. You just have to figure it out. The student, or in the lingo, the agent, learns purely by doing. It tries an action, sees what happens, and gets feedback. Good moves get a reward, maybe some points, and bad moves get a penalty. And this just happens over and over in a continuous loop. The agent acts, the environment, the game, responds, the agent gets feedback, either positive or negative, And then it learns from that feedback, adjusting its strategy to get more rewards next time. Now imagine doing that millions, even billions of times. That's how it eventually figures out the absolute best strategy to win. This trial and error approach, this is the magic behind how AI can master incredibly complex games like chess and Go, even beating the best human players in the world. So that's the what. We've got our three main ways machines learn. But how do people actually build one of these systems, like from the ground up? It might seem super complex, but there's a pretty standard blueprint that almost every project follows. Okay, so first things first, you start with preprocessing. This is absolutely crucial, and honestly, it's where most of the work happens. You're taking raw, messy data and cleaning it up, formatting it, and just getting it into a usable shape. Once your data is clean, then comes the fun part, training. This is where you feed the data to different algorithms and let them learn, trying to find the one that builds the best predictive model. But you're not done yet. Finally, you have to do evaluation. You take your best model and you test it on a fresh set of data it's never seen before. You have to see if it's actually any good, if it's accurate. And only if it passes that final exam with flying colors is it ready to be deployed out into the real world. So when you put all these pieces together, you have this massive amount of data. You have these different learning strategies, and you have this structured process to build with. You end up with something that is, frankly, transformative. And here's the real takeaway, the most important thing to remember. Machine learning isn't really about creating a thinking machine, not in the way humans think. What it's really about is having a powerful tool that can take these enormous mountains of raw data and transform them into something useful, into knowledge, into patterns, into intelligent predictions that can help all of us make smarter decisions. At its heart, machine learning is a tool for finding answers, sometimes to questions we didn't even know how to ask in the first place. So I want to leave you with this thought. Knowing that this technology can turn raw data into real knowledge, if you could point it at any problem, what would you want to solve?